Today, lesson 17C, making inferences from random samples. Yesterday, we talked about the idea of what a random sample was, in addition to biased situations and unbiased situations. And today, I kind of run a little demo for you where we can make some inferences from that. And then tomorrow, you'll be doing things on your own in addition to the next lesson after that as well. Okay? So let's go ahead and get started. So some background knowledge. We defined all of these things yesterday, what a sample was, what a random sample is, and what we mean by population. And we also talked about why we take a sample, and basically it's because in many cases it's too expensive and too time-consuming to survey an entire population. So let's just go ahead and get started for today. Your math teacher has a bag full of marbles. The teacher states, there are 100 marbles in this bag. Some are red, and all of the others are blue. I want you to estimate how many red marbles are in the bag without looking in the bag and counting all of them. So what we're going to do is we're going to do some random sampling to see if we can kind of figure that out. Okay? So here's what I tell you. You reach into the bag and you pick out 10 marbles, and 4 of them are red. How many red marbles do you think might be in the bag? Well, you can make a guess, and if we did another random sample, your guess might change. Okay? So that's the first random sample. So let's pretend like you put the 10 marbles back in the bag. Now you reach in, you pick out 10 marbles, and this time you pick 6 that are red out of the 10. Now I could ask you to make a guess as to how many red marbles you think are in the bag now. And that's probably different from what happened the first time. So let's pretend like you put the 10 marbles, those 10 marbles back in the bag. And this time you pick out 10 and 9 of them are red. And so if I ask you to make a guess again, it's probably going to be different than the second time and the first time. Okay? Here's what I want all of you to do right now. Just make a guess. Just write it somewhere off to the side. Make a guess on how many red marbles you think are in the bag. Okay? Remember, we did some random sampling. There are 100 marbles in the bag. Some of them are red, some of them are blue. I reached in, or you reached in, grabbed 10, and 4 of them are red. Then the second time you reached in, we put the 10 marbles back. The second time you reached in, grabbed 10, and 6 of them are red. Put all those back, and then you reached in, grabbed 10, and 9 of them were red. Why do you think we got a different number of red marbles each time? Yeah, we're basically running an experiment or a simulation here, and we're going to use the idea of random sampling to try and hopefully figure out something close to the number of red marbles that are in that bag out of 100. All right. Random samples can differ from one another due to random variation. And I know we've got some blank areas to fill in here. Once again, random samples can differ from one another due to random variation. All right, so as you can clearly see below that, I have started a table where I've included the first 3 trials. Trial number 1, we picked out 4 red. Trial number 2, we picked out 6 red. Trial number 3, we picked out 9 red. And one other thing, the variations can be small, but occasionally it could also be much larger. Like the difference between the first 2 draws was small, but then in that third draw, I drew a lot more red marbles than I did on the previous 2. That's what that really means. In order to get a better estimate for the number of red marbles in the bag, we need to do more random samples, and that's what I was getting ready to say as far as the table goes. So we're going to do 17 more draws and log all of them in the table and then plot them in a dot plot. So this idea of a dot plot, like the idea of a line plot, you did in the 6th grade, maybe even in the 5th grade. And it's just an easy way of keeping track of how many we have. Okay? So you can go ahead and On the 4 pole, put a circle. When we did a line plot, we typically put X's. This is called a dot plot because we're using dots. Then the second draw, we got 6, so let's put a dot on the 6. Then on the third draw, or the third trial, we drew 9 red marbles out of the 10, so we put a dot on the 9. So those are the 3 trials we already did. All right, so let's do some more trials. 4th trial, we drew 8, so fill that in the table, and then fill that in on your dot plot. 5th trial, we drew 10 red marbles. So all 10 of them that we picked were red. And as I'm saying these, you're filling in your table once again, and then filling in your dot plot. 6th trial, we drew 7. 7th trial, we drew 10 again, which is kind of weird, but sometimes things like that happen. 8th draw, or 8th trial, we drew 7. 9th trial, we drew 5. 10th trial, we drew 8. And I'm going to stop for a second to let everybody get caught up, make sure your table is correct, and make sure that your dot plot looks like mine. All right, we've got 10 more trials to go. Now, when we do these kinds of things tomorrow and the next lesson, you're going to be doing these on your own, kind of like we did when we first started the idea of modeling. I did some experiments for you one day, and then the next 2 days you did your own. 11th trial, you drew 7 red marbles. 12th trial, 9 red marbles. 13th trial, 7 red marbles. 14th trial, 8 red marbles. 15th trial, 8 red marbles. And I know that we have 5 more trials, but as you look at your dot plot, it should start to become clear approximately how many red marbles we have. Okay? 16th trial, 7 red marbles. 17th trial, 5 red marbles. 18th trial, 9 red marbles. 19th trial, 4 red marbles. And 20th trial, 6 red marbles. So I'm going to stop and make sure everybody's caught up, have their table correct, and make sure that your dot plot looks exactly like mine. All right, below your dot plot in your notes, you have some blank areas based on what we just did. I would like you to fill in those blank areas. And we may have to change them, but that's okay. So do the best you can on filling those in and answering the questions. And I'll get back to you in about a minute and a half. So I walked around while you guys were talking about that, and pretty much everybody had the same thing. And they put about 7 out of every 10 marbles are red, or about 70% of them are red. Now, it should become clear, hopefully, why that is. I mean, if you look at your dot plot, it looks like we have more, we clearly have more 7 out of 10s than we do anything else. So that gives us some sort of indication that it might be 70-something marbles. And then I think the last question was, if that is the case, about how many red marbles are in the bag. If you didn't answer that question, answer it right now. Now we're going to come back to that and see how close you really are. Okay? All right, so sometimes we do things like this to try and figure out in this case, how many marbles are in a bag. But sometimes we use something else. We use what we call measures of central tendency. And one of the things you did in the 6th grade is you learned how to find the mean and the median and the mode and the range. And these are all what we call measures of central tendency. So we're going to take and we're going to order numbers from least to greatest. But what we're going to do is, we're going to go ahead and do that for all the marble situation there. So this is basically all of those picks that are all of those trials in order. We had 2 4s, and then 2 5s, and then 2 6s, and then 5 7s, and then 4 8s, and then 3 9s, and then 2 10s. And obviously you should be writing these down. And then we're going to find those measures of central tendency. Now, for this problem, so we can get through it, I think you all remember from 6th grade how to find the mean. To find the mean, it's the sum of all the numbers divided by how many numbers you have. Do you remember that from 6th grade? Yeah, okay. And so I'm going to go ahead and add them all up for you, and we know that there are 20 numbers. So they all add up to 144, and we have 20 numbers. So I'll let you take that and find the mean. And let's not do any rounding. All right, so 144 divided by 20 is 7.2. So according to the average or the mean, or what you may have called fair share last year, that means about 7.2 out of every 10 marbles is red. That's what that means. Okay? How do you find the median? Uh-oh. Come on, that's one of the easiest ones. You find the number in the middle. Now, what if there isn't one middle number? What if there are 2 middle numbers? Because sometimes we run into that.
There's 2, add them together and divide it.
Yeah, and that's what you're told to do, right? Add them together, divide by 2. I think of it a different way. What number would go right in between them, perfectly in between them? Because that's really what you're looking for. And in about 5 minutes, that is the way you kind of need to think about that. So here, the median, I usually basically start from one end and start at the other end and start crossing numbers out until I get to the middle number. Especially when you have a lot of numbers, it's hard to really keep track of what's going on. But in this one, guess what? There are 2 middle numbers. So the number that goes right in between 2 7s is a 7. Or if there are 2 7s in the middle, 7 plus 7 is 14 divided by 2 is 7. So the median is 7. So according to the median, about 7 out of every 10 marbles is red. Then we have the mode. How do you find the mode?
The most matters, right?
Yeah, so it's the one that occurs the most. Which number occurs the most?
7.
The 7. So according to the mode, about 7 out of every 10 are red. So all of these pieces of information tell us that about 7 out of every 10 marbles in the bag are red. So in other words, there's 70-something red marbles in that bag, more than likely. 70-something. Now the last measure of central tendency, which really doesn't come into play here, but it comes into play in the next thing, and that's the range. And to find the range, you're trying to find basically the difference between the largest value and the smallest value. You probably were told last year, take the biggest number and subtract the smallest number. That'll work. So the range here is 6. All right, so now we've talked about measures of central tendency, but we've got one other thing to talk about as far as trying to figure out how many red marbles are in this bag, and that's the idea of another type of plot. We talked about line plot and dot plot. That's from 6th grade. We also sometimes utilize something called the box plot or the box and whisker plot. This is something else that you were supposed to do in the 6th grade. I don't know whether you did or not, but it's really pretty easy to do. So we're going to come back to the marble problem in a few minutes. Right now we're going to learn how to create a box plot, or sometimes, once again, it's called a box and whisker plot. So the data below represents a series of random samples. Doesn't matter what it represents. Okay? So the first thing we have to do when we are creating a box plot or a box and whisker plot is we have to rearrange the numbers from smallest to largest. The same thing we would do if we were finding the median. Okay? So 2 is the lowest, and then 5, and I'm just going to help you along here because I know all of you know how to do this. So right now I'm putting them in order from smallest to largest, and 11 is the median there. And we do need the median, by the way. So we put the numbers in order from smallest to largest, or smallest to biggest, however you want to think about that, and we find the median. Now, we also have to find what I call the median below the median. Think about that for a second. The median below the median. So all those numbers I highlighted in blue there, those are all the numbers that are below the median. So we have to find the median of those numbers. This is what we call the lower quartile. What's the median of all of those numbers below the median? Tell me, please.
6.
It's 6. Okay? That's called the lower quartile. That's the median below the median. Then we also have to find the median of all the numbers above the median. That's called the upper quartile. So what is the upper quartile? 13. Okay? Not really complicated. So now that's really all the work that we have to do as far as creating a box and whisker plot. We now just have to draw the box and whisker plot. All right? So here's what we're going to do. We're going to take everything that we just did there, and we're going to create a number line. And we start our box and whisker plot by plotting, and I just went from 0 to 25 there, by plotting the smallest number. Well, the smallest number here is a 2. That's called the minimum. So I put a dot below or above the 2. And this is where you really need to follow along here and keep up. All box and whisker plots or box plots have 5 dots. 1 for the minimum number, 1 for the lower quartile number, 1 for the median, 1 for the upper quartile number, and 1 for the biggest number or the maximum. So I'm also going to put a dot there at 25. Now remember, the 2 and the 25 come from the fact that the smallest number in this list of numbers is 2 and the biggest number is 25. Everybody okay with that? All right. Now I'm going to plot the lower quartile, which I found a minute ago. That's a 6. Then I'm also going to plot 11, because that's the median. Then I'm also going to plot the upper quartile, which is 13. This is sometimes called a box and whisker plot. Box and whisker. First thing we're going to do is we're going to draw a line from the minimum to the maximum, like that. We're just connecting all of them together. That's where the word whiskers comes from. Now I have to draw the box part. Well, for the box part, we basically just put a rectangle around that and put another little line right there. So this is a box plot or a box and whisker plot. Now, before I actually have you create one on your own, a couple of things here. The range is found from the distance between the minimum number and the maximum number, which happens to be 23. Sometimes we're asked for the interquartile range. The interquartile range is the distance from here to here, because it's within the box. What's the interquartile range? What would that be? Just tell me. What would it be? It would be 7. 13 minus 6. Okay? One other thing to look at here. This is broken into quartiles. Here's what this means. 1/4 of the numbers up above fall between here and here. 1/4 of the numbers from up above fall between there and there. And if you don't believe me, look up above. 1/4 of the numbers fall between here and here, and 1/4 of the numbers fall between here and here. That's why we call this lower quartile and upper quartile. We're breaking it up into quarters or quartiles. Okay? All right. So now, in order to construct a box and whisker plot, you need to find the minimum number. You get that from putting them in order from smallest to biggest. You need to find the lower quartile, which is, once again, the median of the numbers below the median. You have to find the median. You have to find the upper quartile, which once again is the median of the numbers above the median. And then we have to find the maximum number, which once again you get that from putting the numbers in order from smallest to largest. All right. Number 3, make a box and whisker plot for that data. I'll get back to you in about 3 minutes. So number 3, we have to start by putting them in order from smallest to biggest. So it should look like this, and you need to make sure you get all those numbers written in there. And then we need to find the median. Well, this time we have 2 middle numbers. So the median is 14. Now, this is what makes this problem different than the other one. Notice that 14 is the median. If you're going to find the lower quartile is the median below the median. So all of the numbers that are below the median are all of those numbers right there. Right? You have to make sure you include that second 13 because it is actually below the median. Because the median is not 13, it's 14. So when we find the median below the median and the median above the median, in other words, the upper quartile and the lower quartile, we have a situation where we have 2 middle numbers again. So the lower quartile is actually 11. And the upper quartile, we end up with the same kind of deal. And that is, of course, 17.5. So this is how you have to deal with it if the median from the original set of numbers comes from the mean of 2 numbers, like in this situation. All right, so now we have everything we need to know to make our box plot or our box and whisker plot. So our minimum number is 3. Our maximum number is 20. Our lower quartile is 11. Our median is 14. Our upper quartile is 17.5. I noticed a couple of you, when I'm walking around, you don't have dots to represent each of those. You've got to make sure you have 5 dots on your box plot. Now you create the whisker part of it. And of course the range is 20 minus 3, which is 17. And then if you were asked for the interquartile range, it would be the distance from there to there, which would be 17.5 minus 11, which is 6.5, if you were asked for that. And then that's what our box and whisker plot should look like. Okay? So now we're going to return to the marble problem. These are the numbers that were there, and I would like you to go ahead and create a box plot or a box and whisker plot from that. Okay, so we take that data, and we already know that the median is 7. So notice that I put a 7 up there because there were 2 middle numbers right here. So we have to put another 7 up there because when we're finding the lower quartile, we are finding the median below the median. When we're finding the upper quartile, we're finding the median above the median. And if you're going to mess up, that is where you will mess up. So let's try and make sure that that does not happen. And our lower quartile ends up being 6. Our upper quartile ends up being 8.5 or 8.5. And so now we need all we need to create our box plot. Minimum is 4. Sometimes I put the dots below the number line. Sometimes I put them above. It doesn't matter. You can go either direction. That's why I changed it up on this one. Lower quartile, median, upper quartile, draw the whisker, draw the box, and then there's a chance you may be asked more questions from that, like what's the range, like what is the interquartile range, and things like that. The interquartile range, by the way, is 2.5. 8.5 minus 6. All right, this is a problem that did not make it into your notes. Who can tell me what the minimum is?
11.
It's 11. Who can tell me what the maximum is? All we're doing here is reading the box plot. Yes?
60.5.
Well, yeah, it's kind of hard to tell because it's not there, but I think it's actually closer to 61. It's kind of hard to tell. Range.
49.
49. Okay, 61 is the largest number minus the smallest number. That is 49. Median.
39 and a half.
Well, I think it's actually 39. It's halfway between 38 and 40, right? Because these numbers are by twos.
Oh.
Okay? Same thing with the biggest number. That was like halfway between 60 and 62, right? Upper quartile.
46.
Upper quartile looks like it is 46. Lower quartile
24.
looks like it's 24. Interquartile range.
22.
It's 22. We just take upper quartile and subtract the lower quartile. All right, we are finished for today.